Hey guys, welcome to Pep Coding. So in this video, we are going to discuss another new question of our arrays and string series, which is majority of element. Alright, majority element. So we'll be given an array of size n, and in this question, we have to find the majority element and print it if it exists, and otherwise we have to print no majority element exists. So let's discuss now what majority element is. So let's say if there is some number in my array that has a frequency that is greater than my array length by 2. Alright. So we can consider that element to be an array, that element to be a majority element. And then we have to solve this problem in linear of time, and linear time that is in order of n time and in order of 1 space. Alright. So let's suppose this is my array. Okay. So here the frequency of 1 is 6, frequency of 2 is 1, frequency of 3 is 1, frequency of 4 is 2. Alright. So the frequency of n, that is 1, is greater than n by 2, which is greater than n by 2. N by 2 here is 4 because the size of my array is 9. So n by 2, which is 4, which is greater than 6, right? 4 is lesser than 6, so my 6 is greater than 4. So I can consider this to be my majority element, right? Now the frequency of 2, that is 1, which is less than n by 2. Here also the frequency of 3 is less than n by 2. Here also the frequency of 4 is less than n by 2. So my majority element here is 1. Okay. So I hope I was able to make it clear what is a majority element. Now let's discuss the algorithm, like approaches, how we can solve this. First, brute force method that comes to my mind is of order of n square time. We have constraint here that we have to use, so my time complexity should be order of, like it should be of order of n time or linear time, and my space complexity should be of order of 1 time. All right. So my brute force method says that I calculate the frequency for every element. Okay. So I calculate for this one, it comes 6. For this one also, it comes to 6. Because for this one, I calculate the frequency for the whole array. For this one also, I search for the same element in the whole array, right? For this one again, frequency is 6. For this two, it's 1. So it is going to take order of n square time, right? Because for every element, I am looking for another all other n elements, right? So so it is going to take order of n square time. Now, because for every element I'm searching in the whole array, right? Now then comes my second method, that is my hash map method. All right. So my hash map method says against every value put its frequency. So let's say for 1 I put 6, for 2 I put 1, for 3 I put 1, for 4 I put 2. So it is going to take at least it optimize our time, but it is going to take order of n space. In terms of space, this is not optimal because it is going to take order of n time. We have to solve this in order of 1 time. Why it is going to take order of n time? Because in worst case scenario, I can have all my elements to be distinct, right? All the elements of my array can be distinct, right? Let's say my array elements are like this: 1, 2, 3, 4, 5, 6, 7, 8, and 9. Okay, so now all the elements are distinct, so I have to make 1, 2, 3, 4, 5, 6, 7, 8, 9. My hash map size is going to be this much, up to 9. So it is going to take order of n space, right? So we don't have to use this method, or also not this method, right? We cannot use these methods. Now, what method do we have to use now? So I say I'm going to use pairing method. Let's say what is pairing method. In pairing method, if I arrange this in this manner, let's say I have 1, 1, 1, 2, 3, 4, 4, and this 1, 1, this 2, 1 also here. Okay, if I arrange this in this manner, so I am going to pair these elements. So now I look here, these values similar to this is also similar to this is also similar to this is also similar to this. Then this value is distinct to this, so I pair this 1 with 2. All right. Now I am remained with these 4 ones. Now I decrease its frequency. It is paired with 2, right? Okay, this one is paired with this 2. Now this one will be paired with this 3. All right. This one is paired with this 4. This one is paired with this 4. So now my 1 is remained unpaired. So my this one can be a valid candidate to be my majority element. It, because it is my potential candidate, it can be my majority element, right? Okay, so now let's discuss again what this pairing method says. Pair distinct element. Okay, it says pair distinct elements. Okay, so now if I pair distinct elements, my array, what was my array? My array was 1 1 2 2 3. Let's say my array is 1 1 1 2 3 4 7 6 6 and 9 9, sorry, 2 6 6 6 and 7 9 9. Okay, this is my array. Okay, so this is my array. Now what am I going to do? First of all, my initial value is, let's suppose 1, and my count is initially equal to 0 1. All right, my initial value is 1. I check this value with this value, so these both value are same, so I'm going to increase my count to 2. Now this value is also again equal to AR of IDX, so I'm going to increase my count to 3. Now I found this 2. This 2 is distinct from this 3, so I'm going to pair this both. I'm going to pair this 1 with this 2. So now I decrease my count to 2, because my 2, now I have 2 ones that are unpaired, right? This one and this one. Now I again check. Now again my value is equal to 1 only, because I have not modified my value. I'm just increasing my count. Now I again found another value, another AR of IDX, which is not equal to my value. So what I'm going to, I will map this 1 to this 3 and decrease my count to 1, because my only one is remained unpaired. Now I again look, is it equal to my value? It's not equal to my 1, so I am again going to pair this with this 4. So my count now become equal to 0. So as my count become equal to 0, what am I going to do? Now I'm going to assign my value to this value, that is 6. Now my value become equal to 6. Now my count for 6 is 1 initially, because from here we have to search. This is my initial value now. Okay, now I check if this 6 is equal to this 6. Yes, it is. If this value is equal to AR of IDX, yes, it is. So I'm going to increase its frequency. I again check, is this AR of IDX is equal to my value? Yes, it is. So I'm going to increase its frequency again, which is equal to 3. Now I'm going to check, is it value equal to my AR of IDX, which is 7? No, it's not. So what I'm going to do, I will pair this 6 with my 7. If I have paired this, so my count is decreased, because there are only 2 remain unpaired 6s. There are 2 6 that are remain unpaired. Now I again increase my index and check my value with this 9. Are these value equal? No, these value are not equal. Yeah, not equal. So map this 6 to this 9. Decrease its count. Alright. Now check again with this value. Is it equal to my, now again check this 9. Is it equal to my value? No, it's not. So map this 6 this 9. Okay. So I map this 6 with this 9. Now count become equal to 0. And my ARR of 9 and my value become equal to what? ARR of I. Because when count become equal to 0, my value become equal to my AR of I, which is equal to 9. So I say this 9 can be a valid candidate. Valid candidate to be my majority element. Okay, so I have found this majority element, like I have found a valid candidate to be my majority element, and then I make a method which returns me a valid candidate to be my majority element. Suppose it returns me 9. Now my n here is equal to what? My n here was 1 2 3 4 5 6 7 8 9 10 11 12. Okay, my n was 12, so my n by 2 is going to be equal to 6. So now I check the frequency of 9. I run a for loop in my method, and then I check the frequency of 9, which is equal to 2, and then I check, is it greater than n by 2? It is not greater than n by 2, because n by 2 is 6, which is not greater than n by 2, right? So this is not my, then we'll print no, like then we are going to print no majority element exists. All right, now let's take an example where my majority element exists. All right, now let's take my initial array, which is this. Let's take this array into consideration. Okay, this is my array. I'm going to erase this. Wait, I make my array here, which is 1 1 1 1 1. I am arranging in this way. 2, that is a smaller value first. 3 3 4 3 4 4. All right. Now my value is initially equal to 1. My count is initially equal to 1. I check if is my value equal to my AR of IDX. Yes, it is. Then increase the count to 2. Now I again check is my value is equal to my AR of IDX. Yes, it is. Increase the count to 3. Again check is my value equal to my AR of IDX. Yes, it is. Increase its count. I again check and increase its count to be 5. I again check my AR of IDX. Is it equal to my value? No, 1 is not equal to 2. Then what am I going to do? Map this 1 to this 2. Alright. That is map this 1 to this 2. Alright. And decrease my count to be 4. Okay. Now I again check this value. Is it equal to my 1? Is it equal to my value? No, it's not. Again map this 3 to this 1 and then decrease the count. I again check this 4. Is it equal to my value? No, it's not. Then map this value to my count. Map this value to my AR of IDX, right? Map this value to my 1. Decrease the count to be 2 because there are only 2 ones that are remained unpaired. Now I again check this. Is this AR of IDX is equal to my value? No, it's not. So again map this 1 to this 4. Decrease the count. Now my count is equal to 1. I am going to return my value. Okay, return this value. Alright. So my this one can be my majority element. So my n here was 9, n by 2 is equal to 4. Okay, and here the frequency of 1 is 5. So so this one is going to be my majority element. Alright. So I hope I was able to make it clear to you guys that whenever, first of all, we'll be keeping 2 variables, value and my count, and then we'll be checking. And then we'll be checking initializing my value to be ARR of 0 and my count to be 1 initialized, right? And then I'm checking for another element like index at like value at every next index, right? Then I check if it matches my value, I'm going to increase the count, and if it does not match my value, then I'm going to map my value to that element, right? And decrease my count to 1. And when my count become equal to 0, it means no elements are remained unpaired. Then what am I going to do? I'm going to assign that AR of IDX, like that particular element at index I, to my value, and then going to check for another pair of that value also, right? Okay. All right. So I hope I was able to make it clear to you. So let's write some code for this. One thing that we have to keep in mind is that whenever my count reaches 0, I have to initialize my value to some new element. Okay, because here when I've assigned my all the 3 to this 2, 3 and 4, my count become equal to 0. In this array my count become equal to 0, and if my count become equal to 0, I again check for this 6 now. So now my value become equal to my ARR of IDX. Okay, all right. So now I check to this value. Is it going to be my valid candidate for my majority key or not, right? We are going to do this till I reach the end of my array. Okay, so let's start writing the code for this. Now first of all, we will be having majority element. So first of all, let's make my one method which is going to return me a public static int, which is going to return me a valid value, that is valid candidate. Okay, its name is valid candidate to be my majority element, candidate. Okay, pass my array. Now what am I going to do? I will make a value variable which is equal to ARR of 0 initially, and then int my value there will be my value and there will be my count, which is initially equal to 1. Okay, then traverse through the whole array and map distinct element. Okay, my I is equal to 0, I less than ARR of length I plus plus. I will check if val is equal to AR of, if my AR of IDX, ARR of I is equal to my val, then what am I going to do? It means I'm going to increase its frequency, right? Increase the frequency, that is increase the count plus plus. Okay, else if it's not equal, then decrease its count. That is, map it to someone and then decrease the count. Let me write here, map the value to some distinct element. Okay, now and then decrease the count, right? And now one condition we had, if my count become equal to value equal to 0, then I change my value, that is I check for another element, so my value become equal to ARR of I dx, ARR of I, sorry, and my count is again initialized to be 1. Okay, then we are going to return my last value, that is the number that is remained can be my valid possible, can be my valid candidate, so return value. Okay, all right. So now in this method I will make a val variable which is going to return a valid candidate. So write valid candidate, I'm going to call this method valid candidate ARR. It is going to return a valid candidate, then I'm going to check for its frequency now. For int I is equal to 0, I less than n is equal to ARR dot length, then I plus plus, all right, and I plus plus, and check if ARR of I is equal to val, and if it's equal to val, increase the, let's make a frequency variable in freq, which is equal to initially equal to 0. All right, so if ARR of I become equal to value, then what am I going to do? I'm going to increase the frequency variable, frequency plus plus. All right, now here I'll check if frequency is greater than ARR dot length by 2, then what am I going to do? I will print that particular value, system dot out dot print val, otherwise print no such element exists, right? System dot out dot print ln, then print no majority element exist. All right, and then let's try to return. Okay, so let's try to run this. First of all, I made a variable value which is equal to AR of 0, and then a count which is initially equal to 1. Then we run a loop and traverse over all the elements and check if my value is equal to AR of I, increase the count. If it's not equal, that is they are distinct element, then decrease the count. And when my count become equal to 0, I'm going to assign my value a new value, right? New element, and then initialize my count to 1, and then I'm going to return my value. Okay, I catch my value here, valid candidate, and then check the frequency. Okay, it should be LEN GTH here. Line number 12, there is some error. Okay, it should be value here, and then value at line number 12, at line number 39, so is equal to LEN GTH. Now again let's try to run this. Okay, accepted, and let's try to submit this. It needs password. Okay, so let's now try to submit this. Okay, submitted. All right, so now let's try to dry run this code a bit. This thing we have to dry run, so let's try to dry run this. Okay, again, let's try to all right. So let's try run this over our array, which is my array, that is my input. My input array is 2 2 1 1 1 2 2. Okay, 2 2 1 1 1 and then 2 2. All right. So my array is 2 2 1 1 1 and then 2 2. This is my array. Okay, so this is my array which has 2 2. I have made just a rough array, so okay, never mind. Okay, so 2 2 1 1 1. Now I call this method int val is equals to valid candidate ARR. I pass this array. Now it initializes its value to ARR of 0. So my initially my value is equal to ARR of 0, which is equal to 2, and my count to 1. Okay, my count is equal to 1. Now I run a for loop from this 0 till ARR dot length, which is equals to ARR dot length here is my 7. Okay, so n by 2 is going to be what? 3. All right, n by 2 is going to be 3. So ARR of, okay, from 0 till ARR of length. All right, now it checks if value is equal to ARR of I. This is equal to ARR of I, right? So my increase my count to 1. My value is equal to ARR of I, so my count is equal to 1. All right, now else what are we going to do? Decrease my count to decrease my count minus minus. So let's say my count initially was 1, and if I run this loop from ARR of 0, it is equal to my values, and initially let's say my count become 2. Now I increase, because my else condition and this condition is not going to be executed because my count is not equal to 0. It's equal to 2. I check here, is it equal to my value? Yes, it is. So I'm again going to increase my count to 3. When I increase my count to 3, I check to next value, which is equal to 1, which is not equal to my value, right? So my ARR of I is not equal to my value, so I'm going to decrease my count to 2. My count is decreased now because I've mapped this 2 to 1. Okay, now I jump here, right? I again check this 2 with this 1. Like this 1 is not equal to 2, so I'm again going to decrease my count to 1 and map this 2 to my this 1. All right, now okay, now my count, now it again comes here, it checks is my value is equal to ARR of 5. My value is still 2. It checks is it equal to my 1. It's not equal to my 1, like it's not equal to my 2. My 1 is not equal to my 2, so it is going to decrease my count to 0. Now my count is increased to 0, decreased to 0. What it's going to do, it will assign my value to be 1. Now my value becomes 1. Now my value is 1 here, and my count, it initialized my count to be 1. So now my count become 1 here, right? Now it checks for this index, for that is 2, that is 5. It checks if my ARR of 5 is equal to value. Is my 1 equal to 2? No, it's not. So it is going to decrease the count to 0 and map this 1 to this 2. Okay, all right. Then what it's going to do, now my count is 0, so it is going to initialize my value to ARR of I, which is equal to 2 now. So now my value become equal to 2. Okay, now it checks for this value. Is this ARR of IDX, which is equal to 2, is it equal to my value? Yes, it is equal to my value. So this line made my count to be 1. So here it's equal to my value, so it's going to increase my count to 2 now. My count is increased to 2 and it terminates my loop. It returns my value, that is my 2. Okay. Now what is the last value of count? We are not considered about that. We are considered about value, that is this 2 can be my, is a valid candidate to be my majority element. So I return this 2 here. Okay. So in this value, here my answer become 2. Now initially my frequency is equal to 0. I start from the I start from my index 0 and I traverse in my array. Okay. I check if is from index 0 till arrow.length. I check all the possible occurrences of 2. So my frequency become equal to 2, 1, 2, 3, 4. So now my frequency here will be equal to 4. Arrow of length was 7. So 7 by 2 is equal to 3. So is my 4 greater than 3? Yes, it is. So we will print 2 because my 2 is a valid candidate to be my majority element. So my 2 here is majority element, right? So I hope I was able to make it clear to you guys, and I hope you like this video. And if you like this video, please like, share and comment, and thanks for watching.